everyone. Thank you for joining me. Before I start, I want to quickly point out that this presentation is web-based. This is actually a web page running in Chrome. It's been entirely written with Kotlin JS. And if you're watching this online or later and you want to follow with the slides, here is the link at the bottom here, p.kotlin.net/KC23. So my name is Salomon Brys. I'm here to talk to you about Kotlin Multiplatform for iOS developers. And I just want to take a few seconds to thank a lot KotlinCon for having me in this, let's say, amazing venue. And I also see a lot of friends in the room. So thank you very much for joining me. So Kotlin Multiplatform, you all know the story. You start with two very different applications, an Android application and an iOS application, and then you want to share code. So in your application stack, the most obvious layer to share is, of course, the business layer. But sharing the business layer is not the entire story because, let's face it, no business works alone. You need to access databases, files, maybe HTTP servers. So you also need, of course, to abstract inputs and outputs, which is done by the amazing libs that the Kotlin Multiplatform community is providing. And then you're faced with a question. I have two applications that should behave the same, so why not abstract behavior? And that is what we recommend, abstracting business input and outputs and behavior. So now you have two applications that behave the same, but that look different because they are on two different platforms. And yes, I am keenly aware that JetBrains just released Compose Multiplatform for iOS, but let's face it, if you have an application that is that you are providing for users, and you don't want your app to be destroyed on the Apple App Store, you will probably use SwiftUI for iOS and Jetpack Compose for Android. But that's not the full story here. What you also need to do to have a quality application is to provide integration with the platform. That means notification, background work, deep integration, and all that. And that cannot be abstracted because this is deeply dependent on the platform. So what that means, and that's the whole point of this slide, is that it's not because you're using Kotlin Multiplatform that you don't need platform experts. We still need developers that are deeply into Android and deeply into iOS. We need experts to create quality apps, even if we are using Kotlin Multiplatform mobile. Kotlin Multiplatform Mobile does not replace the skill needed by a platform developer to create a quality application because you need your application to be deeply integrated into your platform. And this talk is not Kotlin Multiplatform for iOS development. Okay, we are all developers. We know how to develop. Okay, you have documentation online. If you want to create iOS application with Kotlin Multiplatform, go there. This talk is called Kotlin Multiplatform for iOS developers. And what do I mean by that? I mean that I'm going to try to answer the following questions. What can we, as Kotlin Multiplatform mobile developers, do to improve the API exposed to iOS developers? What can we do to improve communication with iOS developers? What can we do to improve deployment of binaries to iOS developers? And finally, what can we do to improve mutual project engagement with iOS developers? So let's start with, great illustration. We need to work together to have an amazing project. So let's start with our first question. What can we, as KMM developers, do to improve the API exposed to iOS developers? Let's start with a very simple code. You have an enum class. You have an enum class and an interface plane that has a maker model and some equipment such as autopilot, glass cockpit, GPS, things that you can find in small plane. You pass that to iOS and they get this API in Swift. So as you can see, Kotlin enums interfaces are properly supported by the Kotlin compiler. We don't get a Swift enum because Swift enum work radically differently than in Kotlin, but yet we have a very understandable API that our Swift developers can use. But now we go back to our plain Kotlin interface and we make it generic because a plane can be built with different engine. And so we need a way to access this engine. And now this is the code that is generated by Swift. No genericity whatsoever. As you can see, the engine is not a generic type parameter, and that's a problem. That can quickly become a problem, and the problem is Kotlin only interrupts with Objective-C, and Objective-C only supports generic classes. So we need to work with that. The fact that I'm showing Swift code is because, let's face it, iOS developers use Swift code, but Kotlin Multiplatform still generates an Objective-C header. And so we need to program with the Objective-C constraints in our mind. So instead of using an interface, well, let's create an abstract class, because Objective-C do support abstract classes and do support generic classes. And so now the Swift code that is generated is generic, and it works. So we need to factor in the Objective-C constraint in order to provide Swift developers quality APIs. Note that here, the E is not bound by engine, such as it was the case in our Kotlin code, and that is because, in my example, engine is an interface, and Objective-C classes, generic types, can only be bound by classes, not interfaces. So that's also something that you need to bear in mind. Basically, if you're doing generics with Kotlin Multiplatform and exporting an API to Swift developers, you can forget about interfaces. Let's go back once again to our Kotlin class, our plane, and now we want to have a function to start up a plane. You may not know this, but actually starting up a plane is not like starting up a car. There's a whole procedure that you need to do. You need to enrich the mixture, prepare the battery, and all sorts of things. So it's not a simple procedure. It's an asynchronous procedure. So what we want is to provide an asynchronous procedure to Swift. And good news, it works. The Kotlin compiler creates an Objective-C method that has a callback, and the Swift interoperability with Objective-C understands that you can either use that with a callback or with an async function in Swift, which is basically kind of like coroutines in Kotlin. So that works. But now what we want to have is a way to be subscribed to alarms. Because believe it or not, when you're piloting a plane, being aware of alarms is something that is very important. So we provide a callback, a function where you can register a callback, and it returns itself a function that you can call to cancel the registration of the callback. That's not really semantic. If we were addressing Kotlin developers, we would, of course, offer them a flow of alarm, a Kotlin X coroutines flow of alarm. So let's see what this gives in Swift. It gives this. Flow is an interface, so it's not generic in Objective-C and therefore not in Swift, so you don't know a flow of what. And then using that is absolutely not semantic and understandable from a Swift developer perspective. So the problem is Kotlin X flows are not supported in Kotlin Multiplatform targeting Objective-C and Swift. And let me be real precise here, they are not properly supported. Yeah, I know you can still use it with a lot of casts and a lot of intermediary objects, but, you know, a Swift developer would rather resign and find another job than do that. And who can blame them? Who can blame them? So there's an idea. You can use KMP native coroutines, which is a compiler plugin that generates accessors for your flows that makes it easier to use with Swift. Now, the problem is compiler plugins are not yet stable, so it works, but it has corner cases. So let me offer you an alternative solution. You could provide to iOS developers an MP flow class. So what would be an MP flow? It would be a class that wraps a flow. Now, as you can see, the constructor is internal. That means that our flow is hidden and the Swift developers won't see this ugly Kotlin X coroutines flow, core flow, or whatever. It is internal, so it won't see it. And then we provide basically the same function called subscribe, and we allow the callback to be called on the flow. As you can see, the code is pretty simple. And then we, of course, need some code that will be hidden from Objective-C and Swift to access flow and create MP flows from a Kotlin multi-platform perspective. And so that gives the Swift developer an MP flow, and the Swift developer can work with that. They can understand what that means. This is the API that they receive, and as you can see, it is pretty simple. It's an MP flow, and you can subscribe on it, and when you subscribe on it, you get a callback that you can call to cancel the subscription. Okay, so that was the first part. Let's go to our second question. What can we, as KMM developers, do to improve communication with iOS developers? Kotlin likes Objective-C, but Kotlin loves Swift, right? Okay, we all know that's wrong, because Kotlin only interrupts with Objective-C. So the question can be asked, will eventually Kotlin love Swift? And while preparing that talk, I met with a lot of JetBrains people and engineers to ask them questions, and they shared with me that we've decided to stop improving interoperability with Objective-C in order to focus on Swift. Yay! How amazing is that? Okay, so that means it's coming. Maybe not today, not tomorrow, and probably not the day after tomorrow. But it will come. However, there's a downside to this decision. We've decided to stop improving interoperability with Objective-C. That means Objective-C won't be improved, such as there will be no default argument support for Objective-C. But yeah, good news. Kotlin will love Swift. But eventually, in the meantime, we need to do something about it. So in the meantime, you've maybe seen that from the beginning of this presentation, I've shown you Kotlin code and Swift code. And no, I haven't manually written the Swift code that corresponds to my Kotlin code. So how can I get a Kotlin code and provide Swift code to iOS developers? Okay, and there's a tool called SourceKitten, and SourceKitten is a front end to the Apple library SourceKit. The Apple library SourceKit is a library that instruments both Objective-C and Swift code and do some magic between them. And SourceKitten is a front end to that library. So how can I present Swift API to iOS developers? Well, let's start with creating a request. So this is non-trivial, but once you know it's there, it becomes trivial. You need to create a request YAML file. This request YAML file must define the request, and that's the request. There's no why, there's no reason. That's the UUID you need to transform Objective-C to Swift. That's it, okay? It's kind of documented over the internet. So yeah, you need to find this. Then you need to add to this YAML file a bunch of paths, namely Xcode path, your framework directory, and the framework name. And then you create a Kotlin API. Let's say we go back to our simple plain. You compile this Kotlin API, and this gives you an Objective-C header. And you give that to Swift iOS developers, and then they resign, right? Because who wants to read that? Like, they feel they're stuck in the 90s. And once again, who can blame them? They're not using this language anymore in their day-to-day life, so they need to have the mental effort, to take the mental effort to transform that and understand how it will be used in Swift. But hey, now we have a tool. Because this is not cool, we can ask SourceKitten with the request YAML file to take this framework and output Swift code. So I believe that SourceKitten is a widely underrated tool because it greatly improves the communication we can have with Swift iOS developers. When we are creating shared codes, now we have a tool to show them the API that they will use. And we can have an actual conversation about what this API looks like and how can it be improved. So let's go back to our first question. What can we as KMM developers do to improve the API exposed to iOS developers? And now that we know that we can produce Swift header-like Swift APIs, the question becomes, what can we do to improve the API exposed to Swift iOS developers? So let's go back to my interface, my abstract class, plain. And let's say that I want to add this function, listen to ATIS. So in aviation, the ATIS is an automated message that plays in a loop on a given radio frequency and that a pilot is supposed to be listening to before starting up their plane. This becomes the function to Swift. And you might not see a problem about that, but Swift is no Kotlin. And the parameter name of a function becomes the symbol of this function, become part of the full name of that function. What that means is that a Swift developer would need to call this function like this. Plain.listen to ATIS, frec::fric. This is not really semantic. This is not how a Swift developer would write this method. And remember, we want to provide the same level of quality to iOS developer as we want to Kotlin developer. So how can we improve that? If we go back to our Kotlin code, then what we can do is add this annotation. This annotation will change the parameter name in Objective-C and in Swift. And in fact, in Objective-C, the first parameter name is part of the function name. So in Objective-C, it will be listen to ATIS on, and in Swift, it will be listen to ATIS with the parameter named on. And that means that in Swift, it comes from this to this. And this is semantic. This is idiomatic. From the point of view of an iOS developer, this makes sense. This is how you write API in Swift. And this is how we should provide API in Swift. Let's take another example. Let's say that I want a way to fuel my plane. Now, we all know that when measuring volume, there's the correct way and there's gallons. And for, right. And I don't know why, but in aviation, we use a lot of metric units, knots and gallons and all of that. So I need a way to provide both. And let's see the Swift API that is created from that. Okay, this is understandable. We have a volume class with two classes. But once again, we see that from our Kotlin developer eyes, and we think nothing wrong. But from a Swift developer perspective, this is how they need to call their function. Plain.fuel, volume colon dot gallons, gallons colon 12.5. This is not idiomatic. This is not the way a Swift API should be presented. So what can we do to improve that? Let's go back to our Kotlin code, and now we add this annotation. So it's a bit more complicated. It's OBJC name, Swift name, okay? So this annotation basically means, okay, in the Objective-C header, change the way the Swift name of this parameter will change. And in Swift, if a parameter is called underscore, it's a special token, and we'll see that. So as you can see, you need to add OBJC name, Swift name. If you don't add the Swift name, it will also change the name of the Objective-C parameter to underscore, and it will make no sense in Objective-C. And we are only trying to improve here Swift, because the Objective-C API is correct. So we go back to the Swift, and the difference is that now all parameters are prefixed with this underscore. And from a Swift developer perspective, that makes all the difference, because they can call the function as such, which is a lot more understandable, concise, and idiomatic. So as you can see, Kotlin provides us with annotation that allow us to improve the way the Swift API is presented to iOS developer, and furthermore, not only the way it is presented, but also the way it is used. And I strongly encourage you to use those. Let's go to our third question. What can we, as KMM developers, do to improve deployment of artifacts to iOS developers? Well, CocoaPod is officially supported, so there's that. But let's be honest, CocoaPod needs to die. Yeah, okay, so CocoaPod heavily instruments the XD workspace project. It is not an official Apple solution, so yeah, let's speak about the actual solution that Apple recommends, which is Swift Package Manager, which is not officially supported. I've been told that it will eventually be officially supported, but once JetBrains has stabilized the Gradle plugin API, and you know, Kotlin Multiplatform has been in beta for quite a long time, so it may take some time for the Gradle API to be stabilized. So it will be officially supported, but in the meantime, well, let's see first how SPM works. The way SPM works, it's not like Maven. The way SPM works, it's a package is a Git repository. So Xcode connects to that Git repository and downloads the sources of a dependency, the sources of the package, and builds it. And how does it build it? Well, it reads from a package.swift file that describes what do the sources contain and how to build them. And Apple has added a very much needed feature and very interesting feature is the ability to have binary targets. So if you have a binary target, instead of building the sources, what Xcode will do is connect to a file server and simply download the zip, unzip it, and get the XC framework from that. So what do you need now? What do you need to have in order to deploy your XC framework, your multi-platform framework to SPM? You need an infrastructure, a Git repository, and a file backend. But let's be honest, you probably have already a Git repository somewhere, because if you don't, well, I'm sad for you. And a file backend, you can use, I don't know, a Maven repository. This is a file backend. AWS servers, you can use your own server. It's quite easy to have a file backend. But you also need logic. First of all, you need a way to compile an XC framework. And OK, that's Kotlin's job. So That's covered. But you still need a way to upload that XA framework to your file repository, a way to generate this package Swift that describes where the binary framework is, and a way to commit and push that package Swift. And TouchLab has you covered with KM and Bridge. It's a Gradle plugin companion to Kotlin Multiplatform that manages SPM deployment. So that means that now you have a tool that allows you to deploy your package as an officially supported Swift package that can be then simply used by iOS developers in Xcode. So let's go back once again to our first question. What can we, as KMM developers, do to improve the API exposed to Swift developers? And I want to go further. What can we do to improve the Swift API exposed to Swift iOS developers? Remember, at the beginning of my talk, I talked about this class, the MP flow, which translates to this in Swift, okay? It's a way to expose a flow to iOS developers. But that's not amazingly idiomatic. What is the equivalent of a flow from an iOS Swift developers? The equivalent is a combined publisher. So why not provide Swift developers with a function that says, okay, I know you don't really like MP flow, give an MP flow to this function, then you get a publisher. And publishers are from your world. So it's Swift combined, and with that, you can do whatever you want with it. And the code to transform a flow to publisher is actually not that complex. As you can see, it's like 20 lines of code. And it's documented over the internet, so you can find that code everywhere. But as you can see, then it becomes pretty easy to provide a publisher to a Swift developer. But that's Swift code. So how do we provide easily that Swift code to iOS developers? Well, we provide it as a package. It's Swift code. It can be a Swift package. And that means that the package that we provide now has a dependency. The dependency from the Kotlin Multiplatform XC framework. So now instead of providing just an Objective-C framework to iOS developers, we can give them also a companion library and tell them, okay, this is the library which has been generated from Kotlin Multiplatform. I've done my best to improve the Swift API on it with annotation and all that, but I know that this is still perfect, and to make it perfect, here's another package that's written in Swift that makes the facade between the framework and the object that you are used to in Swift. And by using those two packages together, then you can have everything that you are used to as a Swift developers. Which brings me, oh, sorry. I forgot that. There's a feature called multiple namespace generation that is coming. JetBrains is working on that, and what it will allow us as library developer to do is to provide Swift packages companion to Kotlin multi-platform libraries that will then be inserted into XC framework. That will be amazingly useful for library developers. I'm not going to go into details about that, but if you are interested by that, follow KT42248. So, as I was saying, the last question of today, what can we, as KMM developers, do to improve engagement of iOS developers? And I believe that this question is wrongly worded. The correct question is, what can we do to improve mutual engagement with iOS developers? Okay, because you are not going to be interested in my project if I'm not interested in yours. And the very first steps that I would recommend is, improving the Swift API, providing a Swift companion, and that allows you to have a real communication with Swift developers and to understand precisely their needs and how they will use your code. But I don't really have magic answer to suddenly make an iOS developer interested in Kotlin multi-platform, but here are some ideas. First, your Kotlin multi-platform code is compiled as Objective-C, so you need to understand Objective-C. Because it will generate an Objective-C header, and yes, Source Kitten generates a Swift header-like, so you can have a Swift conversation with the iOS developers, but you still need to understand Objective-C. But more importantly, you need to learn Swift. Do not expect an iOS Swift developer to learn Kotlin if you haven't learned Swift. That don't make sense. And then you need to empathize with their pain point, because let's face it, they are real. Okay? There is no proper IDE support at the moment that support both Swift and Kotlin. It's been shared with me that since AppCode has been discontinued, the team working on Kotlin integration on AppCode hasn't been dismantled. So they're still working on something. JetBrains is a tooling and IDE company, so of course it's coming. What is coming, one can only speculate. But at this moment, there is no proper IDE support. And yes, an iOS developer, if they want to intervene on the Kotlin multi-platform code and be able to load it and build it, they need several gigabytes of Android SDK. They're not going to use it. They are actually going to use it only for the Gradle plugin, but still, they need it. And, you know, they're not always OK with that. And when Kotlin multi-platform crashes in Xcode, the stack trace isn't all that semantic, and the memory integration is not perfect. JetBrains is working on that, so if you want to understand how they are working on that, you can follow KT55512. And yes, let's say that an iOS developer wants to change something in the Kotlin multi-platform code. Before testing it into their own Xcode project, they need to load it, build it, deploy it, get it from Xcode, and then they can try it. And if they made a mistake, they need to start over. That's not a happy code test debug loop. So you need to empathize with those pain points, and you need to take time to address them. Maybe there's nothing you can do with those. Maybe you can help them understand how to go away those. Maybe you can fix specifically for your project some of these pain points, but you need to acknowledge them, and you need to take time to address them. From my experience, it's been very useful to dissociate multi-platform from Android. Okay, you need from my experience, we as shared code developer need to treat Android and iOS as equal clients. Because it's pretty easy for us to say, okay, Kotlin is the language of Android, so I'll write in Kotlin and then I'll worry about the iOS API later. But that makes iOS developers feel like second-class citizens, because they are. So, no, what I meant is, because they are entitled to feeling second-class citizens when we are treating them like that. So we need to dissociate Android from multi-platform, because we need everyone to be equally treated from our perspective, and we need to tell them and tell Android that they are also equally treated. And lastly, from my experience, do not try to teach Kotlin multi-platform to all iOS developers of a single team. Find ambassadors. Find ambassadors. Find 1, 2, 3 members of the iOS teams that are interested by Kotlin multi-platform, and then let the team organize themselves of who does what. And this is, to me, a much better alternative than to simply force Kotlin multi-platform onto the iOS team. Because there is absolutely no reason why we can't all work together and create an amazing project. And I want to leave you with a story. So, as I said, when preparing for this talk, I met with Anastasia Kapanina, who is a product manager for Kotlin at JetBrains, to ask them and the Kotlin team a lot of questions. And at the end of this discussion, which was amazingly interesting, Anastasia asked me to tell this to iOS developers. Please tell iOS developers we care about them. So JetBrains and Anastasia do care about iOS developers, and we really should too if we want to push the Kotlin multi-platform narrative. So let me take this opportunity to hugely thank Anastasia Kapanina for every work that she does. She's doing amazing thing to push the Kotlin multi-platform narrative to everyone, including Kotlin multi-platform, and she's always available when we need help. So yeah, let's acknowledge that JetBrains is doing an amazing work communicating with everyone. Thank you, Anastasia. Okay, I'm going to leave you with that. I just going to take 2 minutes for the corporate stuff. I'm Salomon Brys. I created Coding Coders. We are specialized in Kotlin multi-platform mobile and Kotlin multi-platform at large. We are a certified trainer by JetBrains, so we do a lot of Kotlin trainings, whether that's for the Kotlin language or for Kotlin multi-platform mobile specifically. We also do a lot of open source work, which are in the COSI, Coding Open Source Initiative package, and we target, with these open source libraries, a lot of platforms so that you can use them and create amazing apps. And with that, I thank you all very much. Please don't forget to vote. Once again, this is the link to the presentation if you want to access the slides and the code that is presented in them. And yeah, have a nice conference.